Excuse me. I see the yes.
Yeah, so now you can start. I will change from here, or you can operate from
Okay,
there.
thank you. Thank you. I'll ask you to control it
Yeah.
from there. Well, thank you very much, Dr. Parikh. I'm sorry for this delay, but that's the problem of technologies these days. Thank you very much for inviting me, and I'm very, very happy to be with the group. Professor Parikh asked me to talk about handling of tropical fruits, especially about some selected tropical fruits. I'll do that with pleasure. And I thought that I may better talk about uh, tropical fruits in general terms, so I can explain certain concepts that can be applied for most, if not all, tropical fruits. If you can give me the next slide, please, Professor Parikh. Now, tropical fruits are very, very diverse. There are too many. They're still very, very exotic for almost all the global population. Interestingly enough, even for many in the tropics, so many fruits, but not known by most of the consumers in the world. As I mentioned, sometimes not even consumers in the tropic. So many of these diverse, important fruits are still very exotic for most of the consumers in the world, including many in the tropics, interestingly enough. So if we can have the next, please. The very, very few are known in the global market. Several of them are known in certain different tropical regions. And if we can have the next slide, please. There are so many and so diverse in every way, diverse in shape, form, taste, content, uses, etc. Next, please. Some of these, I'm sure you know. Some others are characteristics of other tropical regions. Next, please. And we keep next, please. I'm sure you know quite a few of those. Some of them are important in India or in East Asia or Southeast Asia. Some of them are from tropical Africa. Some of them are from the tropics in Latin America, etc. Very, very diverse, very, very important in many ways. Unfortunately, many of them do not have still common markets. Next, please. Next. So, very too many of these types of tropical fruits in different parts of the world are very important, especially in their regions of origin, in the specific region of the tropics. Important in many ways, still very appealing, almost all of them, even the most known of these, are still very exotic in most of the world population, and not only exotic and appealing, but in reality, they are very important for human nutrition and human health. The case in India is very known of using several of these tropical fruits as uh, important foods, important nutritional foods, basic nutritional foods. Some of these are the most important source of starch for several population in different parts of the world. Common examples of those are the banana, the plantain, the breadfruits, and several others. In India, there are other types that are very important as basic foods. But in addition of being very important as basic foods, including important as source of starch, tropical fruits are among the best sources of phytochemicals. Phytochemicals are very important for human health, for preventing diseases. They are very important sources of different types of vitamins, especially vitamin C and vitamin A, and are very important sources of antioxidants. In addition, many of them are very important sources of minerals. So, all in all, tropical fruits are among the most important food items in different parts, especially in the tropics, where there is a need for basic nutrition and basic sources of health. Next, please. However, I usually compare that with the famous myth, the very, very old myth of an apple a day leaves the doctors away. An apple has absolutely no comparison, not with nutrition, much less as a source of health, with many, so many of tropical fruits which are real sources of nutrition and real sources of basic components for human health. Next, please. Now, they are also very, very important in world trade, or at least very few of them are very important in world trade. Important examples, the banana is among the most important fruit in world trade. Mango is becoming very important. Other tropical fruits are becoming more important in world trade. And probably the most significant things that one should know is that almost all tropical fruits are produced in the so-called developing countries, developing world. That is why the market has not been developed adequately. That's why the knowledge has not been developed adequately, and that's why the technologies for these fruits have not developed very adequately. And because of other reasons, the market have quite a bit of these tropical fruits, but in the processing form, not in the fresh form. There are a lot of processed products from tropical fruits because of the difficulties to get around these fruits in fresh form. The next, please. The reason is that these fruits have very short post-harvest life. They are only at the optimum condition, at the most optimum conditions of handling these fruits. So far, we can only keep them for very, very short time, only very few weeks compared to several months for temperate type of fruits or many subtropical fruits. And the reasons for that are many reasons. Next, please. There are many reasons why these fruits have very short post-harvest life. Problems of handling because of the lack of knowledge and because of the lack of adequate technologies. These fruits have, because of certain metabolic characteristics, have very high metabolism. Any fruits with high metabolism would have short post-harvest life. They produce, especially at certain stage, very high amount of ethylene, and those fruits that produce very high amount of ethylenes are very easily senesced and have short post-harvest life. And probably one of the most important other problems is that all tropical fruits are sensitive to cold. Cold is the most important post-harvest technologies available. The use of low temperature is the most critical, most important, most efficient way of keeping foods in general, but especially keeping fresh fruits and vegetables. Unfortunately, all tropical fruits are very sensitive to cold, are very sensitive to low energy, and we cannot keep them at very low temperature as we do for temperate fruits or for many subtropical fruits, and therefore they cannot keep for long time. Another good reason for their very short post-harvest life is that the tropics, which is excellent weather conditions for humans, are also excellent weather conditions for diseases, for microorganisms, and for pests. There are too many microorganisms, disease-causing organisms, and pests in the tropics that infest these tropical fruits, and therefore these are other sources of deterioration for these crops. And that's another good reason for the short post-harvest life of these products. Next, please. Now, no, the previous one. Now, the previous one, please. Yes, this one. I would, some of the important characteristics of these fruits are the so-called climacteric and non-climacteric. It has to do with this concept, and I will explain this concept. All fruits are classified to either climacteric or non-climacteric. Each one has certain advantages and certain disadvantages. Almost all tropical fruits are climacteric, and I will explain what advantages, but especially what disadvantages that has to do with that. I've already mentioned Another important characteristics that has to do with the sensitivity of tropical fruit to chilling, to low temperature, to the cold. That's a very, very important characteristic that has to do with the handling of tropical fruits. I've already mentioned also the problem of diseases. There are many disease-causing microorganisms in the tropics, same for humans, but also for plants and fruits. And there are so many pests, so many insects in the tropics. The conditions, the weather conditions allow for that, and that causes major problems, not only major deterioration and losses and waste for these crops and the difficulty to maintain them, but also this problem causes some important logistical problems, meaning that these problems sometimes do not allow the movement of these crops from one place to another, from one country to another. There are a lot of quarantine laws that do not allow tropical fruits to move from one place to another, and I will mention that with details later. Next, please. Let's talk about this so-called climacteric and non-climacteric concept, which is a basic concept, but it's very, very important from the very practical standpoint. Climacteric and non-climacteric has to do with the way fruits respire. When fruits or anything else, any plant tissue respires, usually it respires very, very, very high in the beginning. Here is when the fruit is set, when fruit's set. Right? Anything that respires at very, very high level, meaning it will metabolize at very high level, meaning that it will age, it will senesce very fast, meaning that it will have a very short post-harvest life. So we would like the product to metabolize at very low level, meaning that it should respire very low. Now, when the fruit start developing, this respiration start to go down. In the case of some fruits, this respiration will go down until the fruit dies or consumed or processed. But there are other fruits that at certain stage, the respiration out of a sudden starts to increase. It shows a sudden increase. It gets to a climax. And that's what we call the climacteric fruits. We have no idea what the reason for that. But this is very important from the practical way of handling these fruits. So these type of fruits that start respiring very high out of a sudden, getting to a climax, have been called climacteric fruits. Those fruits who do not show this sudden increase are called non-climacteric fruits. Now, almost all tropical fruits are climacteric fruits. Now, this has something to do also with another thing very important for the handling of fruits. That is the production of a gas called ethylene, which is naturally produced by all plants and all fruits. Ethylene is nothing or very low when the fruits start developing and keeps very low for the non-climacteric fruits. But in the case of climacteric fruits, at the time when the climacteric is initiated, there is a very sudden also increase in the production of ethylene. Ethylene is a hormone. It is called the ripening and senescence hormone. Those fruits that produces very high amount of ethylene are senesced very easily, very fast, and would have a short post-harvest life. When we apply ethylene to a fruit, we ripen it, we age it, we senesce it, so it won't have a long post-harvest life. So tropical fruits have this sudden increase of respiration. So at this stage, its metabolism is increases. So its post-harvest life will not be long. And at the same time, at this stage, these climacteric fruit will increase very high amount of ethylene, which will also increase the metabolism and decreases the post-harvest life of these fruits. Next, please. So almost all tropical fruits are climacteric. In fact, the only two tropical fruits that we know that are not climacteric or non-climacteric are the pineapple and the star fruit or carambola, and sometimes are called that way. So practically all tropical fruits are climacteric. There are advantages for that. I'm sure you're all familiar with the banana, if not other fruits like mango, papaya, in certain regions of India, where being a climacteric fruits, the advantage is that you can harvest this fruit before it is totally ripened, when it is in a firm stage where you can send it a long distance. Well, not the case of non-climacteric fruits, where you cannot harvest it before it is totally ripened. And when you harvest it, then sometimes it will not be in the right stage to be handled for a long time, or especially will not be shipped over long distances. Okay. However, climacteric fruits, at least at a certain age, at a certain stage, as we've seen during the climax, will have high respiration rate, will have high metabolism, and that's an indication of a resulting short shelf life or short post-harvest life. As we've seen also, in the case of climacteric fruits, the tropical fruits that are climacteric will have high ethylene production at certain stage when it starts ripening, and having high ethylene production meaning high metabolism and fast senescence and short shelf life. So although the climacteric has certain advantages, practical advantages of when to harvest the fruit and how to handle it, but it also has certain disadvantages that had to do with the high metabolism, which also, when the metabolism is very high, usually the post-harvest life would be short. Next, please. Now, the other big disadvantage or big problem for handling tropical fruits is that all of them, with no exception, are chilling sensitive, are sensitive to the cold, to low temperature. Let me repeat again, and I'm sure and I'm hoping that you all know that the most important technique to preserve food in general, every time item of food, but especially, very especially, for fresh fruits and vegetables, the most important technique is the cold chain, meaning the low temperature. Lowering the temperature is the most important way of keeping food, is the most important way to keeping fruits and vegetables. Everything else, every other technology that you know and you probably heard in this event and will hear is nothing but complement to reducing the temperature. This is a bigger disadvantage for tropical fruits because tropical fruits are very sensitive to this technique to lowering the temperature. When we can, for example, store apple at 0 degrees Celsius, if we keep mango at 0 degrees Celsius, we will lose it in few hours. The same with banana and other tropical fruits. Tropical fruits cannot be maintained at low temperature. So we have a huge disadvantage of that. Okay. Next, please. So, chilling injury or cold temperature cause when tropical fruits are maintained, some of them even for a day or two, they are injured, and eventually, depending on the temperature and the duration of the treatment, they may be lost completely. And you can tell this problem by seeing surface pitting, discoloration, and even ripening, or the fruit will never ripen. It is very common in mango. Sure, you've seen that. Or the development of poor flavors, or the increased decay and the loss of the eventual loss of the fruit when it is exposed to low temperature. Next, please. Most probably you've seen some of these injuries at different fruits, very, very common, and tropical fruits. Next, just to show you some examples of injuries, called chilling injury, low cold or very low temperature injury in different tropical fruits. Next, please. Okay, we still don't know exactly the causes of this major problem. I consider it the biggest problem for the handling of tropical fruits. Some of you mentioned that Professor Parikh asked me if I saw some message that he sent me, because that's a paper that is being written on this topic. This topic is really important because it causes major problems that limits the life, the post-harvest life and handling of tropical fruits. We don't know exactly yet to know exactly what the exact reasons, but there are several theories, and among the most important, and Professor Parikh is expert in that. He will tell you more about it. It has to do with a change of phase in the membranes of the cells and of the organelles of these fruits. It changes it from a regular membrane, functional membrane, to a static, non-functional membrane. So that is how the problem is initiated. That's how the injury is initiated. And that's how the fruit is deteriorated and lost. Next, please. Now, all as I mentioned, that's a big disadvantage. Okay, if we look at the cold storage, so-called cold storage chart, we can see that all fruits, doesn't matter what their origin is, tropical, subtropical, temperate, etc., they all freeze at lower than 0 degrees Celsius. All of them, tropical, subtropical, or temperate, with no extension. Now, temperate fruits, all temperate fruits, and quite a few or several of subtropical fruits, the ideal temperature to hold them is immediately above the freezing point. We consider the freezing point around 0 degrees Celsius. So, for example, most temperate and many subtropical fruits, the ideal temperature to maintain them is around 0 to 3 degrees Celsius. Remember that we've mentioned that the use of low temperature is the ideal, most important post-harvest techniques. So if we can keep these fruits at the lowest possible temperature, which is just above the freezing point, then we can keep them the longest possible. Unfortunately, we cannot do that for tropical fruits. For tropical fruits, these temperatures cause injury, and we need to maintain them, store them, or transport them at higher temperature. At higher temperature, the metabolism will be higher, the ethylene production will be higher, microorganisms will be much more active, and therefore these fruits will not last for a long time. So that's a big, huge disadvantage for tropical fruits in comparison with the other types of fruits, the temperate and many of the subtropical fruits. Next, please. So this is a real problem in tropical fruits. I repeat, and it's very important to repeat, that all of them, there is no exception, all of them are very sensitive to low temperature. Some of them are extremely sensitive. Banana, breadfruit, cherimoya, jackfruit, mamey, mango, etc. are very, very sensitive. Some of them are moderately sensitive, are a little less sensitive, but all of them are injured by keeping at low temperature, which is, I repeat, a very big disadvantage for the way that we handle tropical fruits. Next, please. So you can tell here that the ideal temperature to handle tropical fruits are relatively high. That are much higher than the ideal temperature to handle temperate and many subtropical fruits. Some tropical fruits are sensitive to cold even at temperature as high as 18 degrees Celsius, or some of them as high as 20 degrees Celsius. Some of these are extremely sensitive to the cold. Next, please. Yeah, sorry for that. I don't know what happened. Do you hear me? Do you
Yeah,
hear me?
now I can.
You don't hear me?
Yeah, now we hear you.
Okay, sorry for that. I don't know what happened. Okay, so this is a major problem for tropical fruit, for every single tropical fruit, no exception here. Okay, all of them are sensitive to these problems, and we have to find a way around it, at least, if not solve it. And that is still require a lot of research. And this research will have to be done by scientists from the tropical regions, where these fruits are very important. Nowadays, the only way to control this problem is to maintain the fruit at the ideal temperature, not lower than that. Again, I repeat, I know I'm repeating this many times, but this is a big disadvantage. There are other few things that we do. If we keep the humidity very, very, very high, then that will reduce the sensitivity or reduce the sensitivity to this problem for certain fruits. We use that in Mexico, for example, to send fruits long distances for weeks. For example, if you ever get, I think you do, avocado from Mexico, avocado, especially the tropical varieties of avocados, are very sensitive to cold. So we developed a trick to use very high humidity to reduce the sensitivity of the fruit to chilling injury, and that way we can send it for weeks to get to India or to get to the rest of Asia. And the other thing that we found out is that if we use very high concentration of carbon dioxide in the atmosphere in the fruit, that's another way where we can reduce the sensitivity of the fruit to chilling injury. And that's another of the tricks that we are using, for example, to send some fruits from Mexico for a few weeks to get to long distance markets. There are a few chemicals that are being tested that they can reduce the sensitivity to chilling injury, and there are also some work on molecular biology to develop crops that are resistant to chilling injury based on that theory that I mentioned to you that has to do with the changes of the phase of the membranes of the cells and the organelles. Next, please. Now, here is another important thing that I would like to mention that has to do with all tropical fruits. And I think that's another thing that I meant to mention because it does have still require a lot of research in the tropics. And I think I am talking to scientists and researchers. This is the first decision that one would have to make for handling of tropical fruits is when to harvest a certain fruits. In the case of many fruits, we know on what basis we should make this very important first decision. Unfortunately, we do not have yet the information to make this decision for most of tropical fruits. This is a very important decision because we do need to harvest fruits on the exact stage, not earlier, not later. Fruits that harvested before the ideal stage will not ripen or will not ripen properly or will ripen with very low quality, and that is what we see very often in tropical fruits. Fruits that are harvested after the optimum time, they will have short life. It will have fast softening. It will have increased decay and deterioration. So this decision is the first important decision to how to best handle tropical fruits. Next, please. So we need what we called ideal indices, maturity or ripening or harvesting indices. Every fruit needs to have its index or indices to know when it is mature, when it is ripened, when it needs to be harvested. And ideal indices are only known for very, very few tropical crops. Very unfortunate because there are very few research that have been done and is being done to develop ideal indices for many of the rest of tropical fruits. Next, please. We know the exact maturity harvesting indices for important crops such as bananas, papayas, pineapple, and mango. Although I am not sure if these for mango are being used in India. I haven't been in India for a few years. I've worked especially on mango, and of course, you are the most important country in the world in the production of mango, and I hope that by now you already have that. So we know the exact indices for that. We know exactly when banana must be harvested. We know when papaya must be harvested, when pineapples must be harvested. We really do know when mango must be harvested, and I hope that you use that. But unfortunately, we do not know the indices. These indices require to be developed by research, and unfortunately, we do not know the indices for almost all the rest of tropical fruits, and that is very much needed to start with. If we start with a fruit that are not harvested in the ideal stage, it will not be handled adequate for the rest of the value chain. Next, please. Okay, here is another big problems for tropical fruits. The tropic is beautiful place weather-wise. People love the tropics, even especially those who do not live in the tropics. Okay? The tropic is characteristics with good weather, beaches, good temperature. Okay? Right now, when the temperature is below 40 degrees Celsius in certain places, our tropics here, for example, and I'm sure the same in your tropics, the temperature is beautiful. It's around 30, 35 degrees Celsius. Okay? So that's beautiful. But it's also beautiful for all organisms, for all, not only for humans, for diseases. That is perfect weather for uh, disease causing microorganisms, all types of disease causing microorganisms, those for humans and those for plants and so on. So we always find a lot of microorganisms in the tropics, microorganisms that cause major diseases. In the case of tropical fruits, these are important cause of deterioration, important cause of losses, some of the very, very important disease causing microorganisms, for example, the tropical fruits are the Coleotricum, the Diploidea, etc., and several others. So there are no shortage of disease causing microorganisms in the tropics. Okay? It's not the case in temperate regions because comes winter, kills all the diseases, okay? But it's not the case in the tropics. Next, please. So, of course, we do have several treatments for the control of diseases, control of microorganisms and decay. We do need several pre-harvest treatments, both for prevention and for control. Different ones, I'm sure you know about them. I'll not spend the time on this here. Let's stick with the post-harvest. Of course, we use pesticides before harvest, and we still use them after harvest. In the tropics, there is a lot of need for all the methods that we can, including the unfortunate use of chemicals, the unfortunate use of pesticides. There are a lot of restrictions nowadays. The consumers are demanding less, and in fact, none of these, but we are still short of other treatments and we are still in need of the use of pesticides, so we should use them with restrictions and with intelligence, not to cause problems. But we do have some post-harvest treatments, including, for example, the use of temperature. The use we have developed post-harvest uh, treatments using low temperature, but as you can imagine, we cannot use those for tropical fruits. We can use post-harvest treatment using high temperature, and fortunately enough, tropical fruits seem to be more resistant than temperate and subtropical fruits when it comes to the effect of heat, to the effect of high temperature. And that's why we were able to develop commercial treatments based on high temperature, be based on high temperature in water or based on high temperature in air. Hot water treatments of high temperature or hot air treatments. Next, please. Now, as I mentioned, of course, there are still use of pesticides. Still, pesticides are allowed before harvest and after harvest with a lot of restrictions, legal restrictions, and also consumer restrictions. meaning that something can be legal but not very much accepted by consumers. We should restrict every time more and more the use of pesticide. Use only authorized pesticides, use authorized pesticides in the authorized manner, use them in a controlled manner, use them in an intelligent manner, not to cause problems, not only for consumers but also for us in the tropics. Next, please. However, we try more and more and more to use treatments that are not chemicals, physical type of treatments. Some biological treatments have been developed. There are several ones that are commercials already. And I've mentioned the heat or the high temperature treatments, either in water or in air, have been developed and are being used commercially in a wide spectrum for several fruits. We use them. They are very, very effective. Treatments, for example, with hot water, for 3 to 20 minutes at 48 to 50 degrees Celsius, are very effective in controlling the most difficult diseases in tropical fruits, such as choledotrichum. We are using controlled atmosphere or modified atmosphere, especially during transport, during shipping by sea of tropical fruits. Something very commonly used, very commercially used, low concentration of oxygen, and especially very high concentration of carbon dioxide are very effective to control certain diseases, and they are very commonly used, especially during sea shipping for several weeks. Uh, Sulfur dioxide fumigation, which is used in some berries, some temperate fruits, are not very common in tropical fruit. They can be used or one or very, very, very few tropical fruits, such as lychees. Sulfur dioxide is a very effective antioxidant, but also very effective pesticides against certain diseases. Next, please. Uh, Tropical fruits is an excellent place for insects, for pests. In tropical fruits, we can find every single species of insect that you can think of. Eh? Again, that is because of the nice weather for all organisms, including insects. And especially, we can find in the tropics every type of fruit flies that you can think of, especially the infamous, the very famous Mediterranean fruit fly, the Ceratitis capitata, which can be found almost practically everywhere on Earth these days. No, previous, please. Oh, next. Yeah, that one. Okay. No, previous one. The previous. Yeah. There are other species. Probably you heard about the Anastropha. There are several of those, mostly in Latin America. The Duckus, I think you do have that problem, and several other species. Though the fruit flies are the major problem that restricts the movement of tropical fruits from one region to another, sometimes even among the same country, but especially between countries, because it requires legal logistics. It requires quarantine restrictions. Next, please. And those, next please, okay? So we need systems, treatments for prevention and for control, especially when we have the major problem of the quarantines. For example, I can tell you, I'm sure you know, that your mango is quarantined to arrive to certain countries such as the US. And it's been a problem for many, many, many years. Lately, I think it's been resolved, and I will mention that. I'm sure you know better than me. Okay, but this quarantine treatment is a major problem for moving tropical fruits from one place to another. Logistical problems. Next, please. We do have certain uh, quarantine control systems that are legally approved. These systems would need to be legally approved, and those include certain chemical treatments with a lot of restrictions. There are still some use of things like methyl bromide or hydrogen cyanide, etc., but with very, very, very much restrictions. There are several countries that do not allow them. There are certain system of using cold treatment as quarantine system, but as you can imagine, those systems will not be able to be used for tropical fruits. There are certain quarantine system legally approved that use heat treatment, either air or water, and those are very much used for tropical fruits. Among them, for example, mango and several other fruits. I know that for several years in India, they've tried a method that was developed in Mexico about last 40 years ago, but looks like that it didn't work. We will mention that later. We'll mention the alternative. Also, nowadays, irradiation is a legal treatment and allowed to be used as a quarantine system, and I will explain that further. Or there are certain legal quarantine systems that use a combination of some of these treatments. So we do have certain quarantine system commercially available and legally authorized. Next, please. Next, please. Okay. So when it comes to heat treatment, which is probably so far are the most common quarantine treatments used for tropical fruits, the most important of those is a treatment that developed in Mexico about 40 years ago for mango, which is using hot water at 46.1 degrees Celsius for 65 to 110 minutes, depending on the cultivar and depending on the weight of the fruit. That is probably the most important uh, uh, quarantine treatment used for mango all over the world. It started in Mexico, and nowadays it's used everywhere in all Latin America, in some Asian countries and some African countries. Unfortunately, it looks like for some reason, it did not work for Indian mango to be exported to the US, and therefore India had to find another alternative. There are also several hot air treatments, either dry or vapor hot air treatments that are developed for certain fruits, tropical fruits, and they are commercially being used and commercially and legally also authorized and being available when certain tropical fruits need to be shipped to a region or a country that require a quarantine system. Next, please. Let me talk about, I mentioned modified atmosphere because it's very important for tropical fruits. Modified and controlled atmosphere, meaning that any atmosphere that are different than the regular air atmosphere. The regular air contains 20 to 21% oxygen, minus for those who live in New Delhi. Probably that's different. I don't think that it does have 21% oxygen. Regular air would have 78 to 79% nitrogen, and will have very, very low concentration of other gases, such as very, very low concentration of carbon dioxide. Any atmosphere different than that is called modified atmosphere. But modified atmosphere is when it is different than this air, but it's not controlled. When it is different than this air, but is strictly controlled during all the time, it would be called controlled atmosphere. Both technologies, modified and controlled atmosphere, are being used very, very much commercially in different foods, in all type of foods, in fact, and almost all types of fruits and vegetables for different reasons. Next, please. Now, the use of modified atmosphere and controlled atmosphere has many advantages. It reduces metabolism. Remember when we talked earlier about a fruit that metabolizes very high will have short post-harvest life. A fruit that produces high ethylene will have short post-harvest life. Modified and controlled atmosphere would reduce metabolic activity, would reduce ethylene production and ethylene action, so that fruits would live longer. But modified and controlled atmosphere, something I mentioned also earlier, reduces the activity of microorganisms, reduces also the activity of insects. So again, that's the other reasons why modified and controlled atmosphere reduce the deterioration causes of fruits and vegetables and can increase the post-harvest life of these crops. And that's why, next please, that's why it is being used commercially to eat as for packaging. I don't know if you see these pictures. These are tropical fruits. For example, this is how we send, and it is the same technology now. I know it's used in India. This is something that's been developed more than 40 years ago using modified atmosphere as a package in the box to be able to send this banana, in this case, from anywhere in the world to anywhere in the world. It's used very much to transport not only fruits and vegetables, but all kind of foods by sea over several weeks. Those are the two most important applications that can be used, that are available and used commercially for tropical fruits. Modified and controlled atmosphere are also used to store foods, especially fruits and vegetables, but unfortunately, it's not developed for tropical fruits. But the application of packaging and transport is used for tropical fruit. Next, please. Okay, those are the atmosphere that been developed over the years, the ideal atmosphere, the ideal oxygen concentration that we can use for certain tropical fruits and the ideal carbon dioxide concentration that we can use for certain tropical fruits. Unfortunately, there are still quite a lack of research on tropical fruits on these topics, and we still need to know the ideal atmosphere to be used for the rest of other tropical fruits. And also we need to develop this technology not only to package and transport tropical fruits, but also to store tropical fruit, as it is the case for certain temperate and certain subtropical fruits. Next, please. Next. Okay. We, several years ago, in my laboratory, we developed what we called insecticidal modified and controlled atmosphere. Insecticidal means that an atmosphere that would kill insects and would be used as a quarantine treatments, as an alternative for chemicals and for low temperature, especially for tropical fruits. And we developed an atmosphere, an insecticidal atmosphere with lower than 1% oxygen and more than 50% carbon dioxide. And in few hours, in 2 to 4 hours, we can kill 100% of any type of fruit flies at 20 degrees Celsius or more. And that treatment have been tried, even some semi-commercial and commercial also, and can be used also an alternative. In some cases, we used it for mango, and it's also being used for other crops, including grapes and other crops. Next, please. I mentioned, okay, those are some of the atmosphere that can be used, some of the insecticidal atmosphere that can be used for certain fruits, but still there is a need for a lot of research to try to use this method for other types of tropical fruits. Next, please. Now, there's not much need to this method for temperate fruits, because in temperate fruits you can use low temperature as a quarantine treatment, which is much easier, much cheaper than this treatment. But unfortunately, that cannot be used for tropical fruits. I mentioned the radiation, and I wonder if you know that irradiation is very, very much used over the last 60, 70 years to preserve foods, different types of foods. It's approved. I'm talking about either gamma irradiation or electrons at very high speed or X-ray, especially gamma irradiation, which is very, very much used commercially. It is already approved by the United Nations, by FDA, and by practically all the related organisms. It's very safe for health. We use much lower than these doses. The doses in a radiation called gray. So kilo gray is 1,000 gray, and the irradiation is safe, or at least we know it is for sure safe for up to at least 10 kilograys, meaning 10,000 grays. It has a very effective positive effects. It controls sprouting, and that is the most important use that been when irradiation started to be used about 60, 70 years ago. And now it is used, especially in many countries in Europe. For that, for onion also, it controls metabolism, it delays ripening, it controls diseases, but for that it requires a little higher doses. And also it controls insects. Now, fresh fruits and vegetables, unfortunately, especially tropical fruits, are sensitive to doses of half a kilo gray of irradiation. Half a kilo gray meaning 500 grays. With 500 grays, we cannot kill insects. Insects needs about almost 1 kilo gray to be killed. Diseases also require 0.75 to 1.75 kilo gray to be killed. Okay, so the doses that we need to kill insects and kill diseases will also kill fruits, unfortunately. So we can only use irradiation in fruits in general, including tropical fruits, at